Hello, this is my 225 lab section 2 mux 2 to 1, 4 to 1, and 8 to 1 converters lab. My name is Riley Benavides, and I will get started. So to start off, I did my 2 to 1 mux, which is your basically regular mux with your selective and then your two inputs. So as you can see right here, you have your selective, which is going to be an AND with the A, selective, not selective, an AND with B. And then at the end, you take the two outputs from these two AND gates into this OR gate, and you have a mux. Right here, you can see I defined my variables and my output, and then I wired my not A, not B, my not selective, my A and selective, and my not selective and B. And yeah, that's the 2 to 1. And then from there, I use the 2 to 1 to make my 4 to 1 converter. As you can see right here, it is a bunch of 2 to 1s together. 3 2 to 1s actually, which is what we're going to be doing to make this 4 to 1. And here is the schematic simplified right there. So as you can see right here, my inputs are now D0 through D3 because we are doing 4 to 1, which means that we have 4 inputs and 2 selectives. Yeah, the first selective is going to be going into the two first muxes that we have right here, and then the last selective is going into this final mux. And I called my previous mux function in order to make these muxes. So in my first mux, I have my inputs D0, D1, and my selective 0 to make an output of outmux 1, and that's going to be the output that you guys see right here. And then same thing I did on the second one, so I used D2 and D3 with the same selective 0, which is this one right here, to make another outmux 2, which I defined right there. And then from these two outmuxes, you're going to go into one final mux and use our selective 1. So I define that right here, mux 3, with outmux 1 is A, outmux 2 is B, and our selective as S1 to create another output of our mux. And then I finally used my 2 to 1 converters to make an 8 to 1 converter. As you can see, they have 7 muxes to make your final one, because we're going to have 8 inputs, so D0 through D7, and then we're going to have 3 selectives. So these 3 right here are going to have the same selective, which is S0. This one's going to have S1, and this one is the S2 selective. As you can see right here, I defined all my inputs, D0 through D7 and S0 through S2, and then my final output, outmux. I wired all my outputs that stem from these muxes, so this is outmux 1, outmux 2, outmux 3, and so on. And then the first mux, I have D0 and D1, selective 0 with outmux 1. I have D2, D3, selective 0, and outmux 2 for mux 2, and so on till I get to till I finish my first 4 and get to my 3 in the middle. So we're going to have outmux 1, outmux 2, and selective 1 for these ones with the outmux 5. So as you can see right here, all of these outmuxes lead into these ones, and then I'm calling this one outmux 5 and this one outmux 6, and these ones use selective 1. And then finally we have our last mux to complete the 8 mux converter, and I use my last two outputs from these muxes right here and selective 2 to get a final outmux right there. And we're moving on to our test bench. So this is my test bench for my 4-to-1 mux converter. Yeah, I have all my inputs right here, and this is what the timing schematic looks like. And then I have my 8-to-1 test bench, which is basically the same as this one, but with D0 through D7 and so on. And I don't know why it wouldn't blow up any further than that, but that is what my timing diagram looks like for my 8-to-1 mux. And yeah, thank you.